Hi everyone, today's video is about, well, look no further than the t-shirt, Sinclair ZX Spectrum. I've got a friend who owns a original 48K ZX Spectrum, the original 1980s range of computers made by Clive Sinclair back in the day, and what my friend wants me to do is replace the existing ROM from within the ZX Spectrum with an enhanced version that it can be downloaded off the net. And there's plenty of people over the years have basically modified the original ZX Spectrum ROM and added in extra commands, put in extra functionality and that sort of thing. So there's a ROM out there that my friend wants installed, and this is the ZX Spectrum here. Lovely rubber keyboard, as you can see there, and this particular ZX Spectrum, it's pretty good nick. It's the keys are hardly been used at all, so I don't know how long it's been sitting unused, but it looks like it's basically had very little time on it at all. Well used Spectrums obviously are out there, and you tend to find that the keys are worn. The white lettering on the keys are all sort of browned off where they've been touched a million times over the period. And also the sides of the keyboard here, where the wrist tends to sit, the palm of your hand tends to sit when you're using the keyboard, then tends to be worn. And then, as you can see, there's just virtually no wear marks at all. So in terms of a ZX Spectrum, this one's in virtually perfect nick. The only thing it's missing really is 4 rubber feet off the bottom, which I'll also try and replace with my friend as well. So the purpose of today's video is to obviously take it apart, remove the existing ROM from the PCB. It's directly soldered in, so that'll mean get the solder sucker out, replacing the original ROM with a dual inline socket, and then an EEPROM to plug into it. So down on the workbench now, here's the ZX Spectrum. So we'll start by taking it apart. Just grab the screwdriver here. So for anyone that's been inside one of these before, they're basically dead easy to take apart. I'll just turn it around so we can see. Basically got 5 screws that hold the 2 halves of the case together, and then from within there you can see that the single PCB on the bottom, and there's 2 basically ribbon cables going up into the keyboard, so they're pretty easy just to disconnect. Just need to pull them out of their socket there. That's one, and the other one. Just need 2 hands for this one. That's it. So basically there's the keyboard, so I can put that to one side, and there's the actual ZX Spectrum PCB. So looking at the board here, issue 3B from 1983, my own Spectrum, which is probably in a box somewhere, is an issue 2, so this is a slightly later one at issue 3B, which there isn't much differences really, just a few corrections to the circuit, but nothing major at all. So there's the ROM up on here, a 16K ROM there. So to get at that, I'll need to remove the heatsink here from the 7805 regulator, and also remove a screw in the middle of the board there, which is the only screw that basically holds it in place onto the bottom of the half of the case there. And from then I'll be able to remove the ROM, desolder that there, put a dual inline socket in there, and then make some modifications to the actual PCB to make the EEPROM compatible with the board. The original ROM here is not pin compatible with the EEPROM. It does require a little bit of extra additional circuitry to make it work in place of the original ROM. So this is the actual EEPROM I'm going to use today. It's a 27256. That's a 32K EEPROM. The original ROM here is 16K. The plan is, a friend doesn't know this yet, but the plan is I'm actually going to install 2 copies of the ROM into the EEPROM. The original ROM I'm going to put at the bottom half, bottom 16K, and the new ROM I'm going to put in the upper 16K, and then I'm going to add a switch onto the back of the case somewhere so that you can select the ROM prior to powering up, and that will enable the original ROM to be booted, or the new one as he sees fit via the switch there. So next step is to remove the board from the case and remove the heatsink, and then we can get started. There we go, that's the heatsink and everything else removed out of the way. So now I've got full access to the pins in the back of the board there, and also the top side that I can get the ROM removed. Okay, we're ready to start removing the ROM. So I'm actually going to use my desoldering gun here. Easiest way to get a through-hole 28 pin device like this removed from the board is to actually use one of these. There all day with the hand tool, so let's get going with this. Well, I find the easiest way to use one of these guns here is to, when you actually put it over the pin on the chip, basically let the solder melt and then actually wiggle the gun around just very slightly, and it frees off the pin from the side walls of the through-hole plate in there, and it enables it to suck the solder out a little bit better, more cleanly. So that's one half done, but there is actually a few pins on there that I've not desoldered cleanly, as you can see over here. So I probably need to apply some solder back onto those pins, let it flow through the hole again, and then reattempt it with the desoldering gun. Okay, they've all desoldered quite cleanly apart from that first four, as I said, so I'll just apply some solder back onto them right now. Actually, I think I'll do the first 5. There we go, and then straight back in with the soldering gun. Yeah, that's better. Okay, what you're actually looking for when you're using one of these desoldering tools, whether it's the one I was using or the hand ones, is when you've desoldered, you got a good idea you've done quite a good job, is if you can see actually down into the hole. As you can see there, most of them there, you can see obviously you just see black, so basically you're looking down into the hole. If you see any amount of solder down the hole, then don't try and remove the chip. You want to get it to this sort of state here that you can basically see right down. And then the next step actually is what I like to do is actually, you know, with a small screwdriver or something, is actually push the pin slightly, go along and push them to one side, and it actually helps to free up the pin away from the side wall of the through-hole plating, because you will find that some of the pins get stuck to the side because the pins are, you know, in some holes are actually a tight fit into the hole, so you want to have it as free as possible. The thing you're trying to avoid here is when you actually go to lift the chip off of the board, you don't want to pull the through-hole plating with it, because I mean there will be tracks coming off of the top side, and in actual fact there's quite a lot actually. You can see all those tracks here on the top side are, you know, a lot of them are going onto this row of pins here, and a lot of them are going between those pins and then across to this side as well. So there's a fair amount of tracks here on the top side, so it's you know, there's going to be, you know, quite a good chance if you just start forcing the chip up that you're going to either rip the through-hole plate out, or even worse, pull the track from the board, which is a bit of a nightmare situation in terms of you know, us putting it back together again and getting it working. So first thing I'll do now is, or next thing I'll do now is actually go along the pins down on the workbench there and see how free they are, and if need be I'll actually use a soldering iron to heat up the pin and wiggle it about with the tip of the iron to free it off the side wall of the hole there. Okay, next thing to do is turn the board over. Now I'm going to actually try and lever the IC from the board. So what I'm actually going to use is a screwdriver. Actually, it's just the preferred method I've used over the years. So what you're looking to do is I usually start at one side. As you can see, there's a couple of resistors. There's one at this end of the board, stops you getting the screwdriver nicely under, and of course we've got resistors on this side as well. So I'm actually going to try just coming in under this side. In fact, I'll use a smaller screwdriver here. I'm going to come in at this side here, and what you have to be careful with is don't lever the pin, the end of the screwdriver against the board, because you can actually damage the tracks and the surface of the board there just by using the screwdriver alone. So you have to be careful on that. Luckily at this end of the board it's actually quite heavy, which looks like power tracks going along this end of the board here. So you know, I've got quite a low chance there of actually damaging the board. Another thing you want to do is don't lever too hard. If it's not going to come cleanly, easily, then chances are one or more pins are actually still holding it down. But the only way to find out is actually to give it a go. So that's what we're going to do here. So you can see, well, that's actually come quite easy. Just a slight turn of the screwdriver there, just to give it that little bit of leverage. Now I can go in, and I'm actually just pushing the screwdriver in this direction. I'm not actually levering it up and down the way, you know, like that against the board. I'm just pushing the screwdriver in, and that's enough there just to put a little bit of vertical force on the chip to actually lift it from the board. And there it is. That's it. Chip removed. And then what you're looking for now is I'll just zoom out, sorry. So what you're looking for now is it's worth checking the actual pins on the ROM. If you've lifted the through-hole plating out of the hole, you'll see a little the remains of it still around the pin. But as you can see in this one here, well, I'm hoping you can see, there is no residue of any kind of through-hole plating on the pin. It's just basically the shiny pin themselves. And then this side as well, it's exactly the same. I'll use my there we go. You can just see there, it's just the pins themselves. So the board itself is nice and intact there. And also, as you can see, there's no marks on the top of the board where I've levered it. I mean, there's the very, very lightest of scratch on this top thick trace here where I initially went in with the screwdriver there, but it's hardly even a scratch of the track, let alone a dig right into it. And of course, because I never needed to lever from the other end where there's smaller traces, there's absolutely no you know, scrapes or marks or cuts at all. And also where I went in with the screwdriver in this direction here under the chip, because I'd kept the tip of the screwdriver off the board, there's no scrapes or marks or cuts in the tracks there as well. So it's about as good as a job as you would have hoped. Okay, so would you believe it, I've got any amount of 0.3 inch IC sockets here, but I don't have any 0.6 inches, which I obviously need for the EEPROM space in there. So I'm actually going to go ahead and use a couple of single inline headers here. They're turn pin, so they'll do the job nicely. However, there's actually an added bonus by using single inline in this case here, because if I bring the board back in here, if I put in a normal IC socket, I'm actually going to cover up a lot of the tracks and traces underneath the IC socket, which is, I don't really want to do that because there is going to be some modifications to be made to the IC socket, and at the moment I'm not too sure whether it's on the top side or the bottom side that I need to make those mods. So by using single inline headers like this, it does actually give me access right around in and under the what would have been the IC socket there, or underneath the EEPROM there. So I'm actually going to go ahead and use these here. So we'll cut them to size and get them soldered onto the board. Okay, so that's the IC socket of sorts in place, and as you can see I've just plugged in the EEPROM at the moment to make sure we've got a good fit there, and everything's hunky-dory as you can see. So the next step now is to go ahead and make the modifications to the board in order it can support the 27256. Okay, so what we've got here is actually the schematic diagram for the ZX Spectrum, and it is actually the issue 3 we're looking at here. And right in the middle of the schematic there is the original ROM, which you can see there. And the reason it's not compatible directly with the EEPROM, either a 27256 or a 27128, is because of the enable pins on the original ROM. There was actually 2 pins used, as you can see. They've actually detailed it here. On the NEC type ROM you had a chip enable on pin 20, but you also had a chip select on pin 27, and then in the Hitachi version of the same ROM it was actually the other way around. So basically you had 2 chip enable / chip select pins on the ROM. The problem being with an EEPROM is that you really only have 1 chip enable / chip select, and that was on the pin 20. The pin 27 is actually used for one of the high-end address lines there, A14, which I'll come to later on. But basically you only have the 1 chip enable. So the way around that is actually to put in a couple of diodes, basically an OR gate, which you can either use a 4000 series or a 74 series OR gate to do that, but there's actually an easier way with a couple of diodes to OR these 2 lines here together in order to feed into the single pin on the EEPROM there. All over the net you'll find there's various websites showing you how that's done, and as you can see here, here's the idea here, where you've got the original chip select line and a memory request line here will come in through the couple of diodes here, basically ORed together, and that will go to the new EEPROM pin 20 there, with a pull down resistor as well there. The other modification that's required here, all EEPROMs have got a VPP pin for programming, and in normal operation that pin there would be tied actually to +5 volts, and that happens to be pin 1 on the EEPROM. On the original ROM, the pin 1 wasn't actually used, so that pin is actually free on the board. So it's just an easy case there of linking across directly from the 5 volt pin, pin 28, right across to pin 1. Down at the bottom left hand here is, because I'm using a 27256 EEPROM as well, I'm actually going to use this, as I said earlier, for selecting the bank there. So pin 27 on the EEPROM, if I just bring that up again, is A14. So basically by selecting A14 high or low will effectively select either the top half of the EEPROM or the bottom half of the EEPROM, with all the other address lines being connected to the board. So that's dead easy, basically just a simple switch from 5 volts or 0 volts, basically selecting pin 27 there. There's no need to put any pull down resistors or pull up resistors or anything like that, because the only way this will work is by powering off the ZX Spectrum, selecting the switch and then powering it up. It's not like you're going to be using this whilst it's switched on. We wouldn't be looking to do that. The only other thing we've got on this diagram here is at the top left hand corner there's a little grid network there which shows you the easiest places to pick up the ROM, CS and MREQ lines from the board. There's a little grid network that's already on the board itself, so it's dead easy to pick that up, and actually it's a good place to actually fit the diodes. So we'll go ahead and do that now. So on the board there you can actually see there's the links there. They're actually marked N. There's a pair marked N and a pair marked H. That's for the NEC type ROM, and the H for the Hitachi type ROM. I mean, slight differences in the ROM themselves. You obviously have to select the links accordingly. So the original ROM here is an NEC type ROM, hence the N links are selected there. So first things first is to cut those links out, lift them from the board, and that'll allow me then to fit the diode and resistor. So the diodes I'm actually going to use today are a couple of Schottky diodes, BAT 85Ss. And the only reason behind them is because I'm actually fabricating an OR gate that's going to actually work at 5V logic levels. I really want the volt drop across the diodes to be as small as possible. So it just so happens that the BAT 85Ss have got about a 0.25 volt drop across them, as opposed to your 0.6, 0.7 of your normal signal diodes. So the BAT 85Ss will do the job nicely. Okay, so there we go. That's the two diodes fitted there, and the pull down resistor there, as per the diagram I showed earlier. And I've also fitted the link across between pin 1 and pin 28 there. So the next thing to do is wire up the switch that's going to go to A14 on the IC. As per the diagram that I showed earlier, actually this track here is actually A14, so I can easily pick that up there, and then I'll just need to pick up the plus 5 volts and 0 volts from the supply on the board somewhere. So let's find a suitable switch and mount it onto the board or onto the back of the case. Okay, one way to mount the switch would be just to put a toggle switch actually through the top side of the case here, where there's actually quite a bit of depth, as you can see there, to actually drill a hole and put a switch there. But the problem with that is I'm going to actually be left with some wiring from this side of the case down onto the other half, the bottom half of the case here. I don't really want to do that. I'd rather keep all my electronics in this bottom half, so that this top half is basically as it was with the two flat flexes there down onto the board. So I think I've got enough room at this back end of the case here. There's just enough height, I think. I've actually fitted the small toggle switch there. Switch is actually quite low profile actually. It's nice and flush with the back of the case there, and it just so happened that some of the connections that I needed to use, obviously the middle pin there, it goes off to A14, and you've got 5 volts on one side of the switch and 0 volts on the other, basically to give you 0 or 5 volts on the yellow wire there. It just so happens I was able to drop down almost immediately off the contact down onto a track or a pad and pick up the 0 and 5 volts accordingly, so it worked out perfect there. Okay, the next thing to actually do is to go and burn an EEPROM. I just bought this cheap Chinese EEPROM programmer from eBay. It's probably just one of the cheapest ones that's on there actually. It's a G540. So I've loaded it up, I've got the drivers loaded, so let's get over to the PC and actually see if we can do something here. Okay, first things first, let's run up the software. Okay, I've already been into this before, but I'll just go through the motions of exactly how we go about programming EEPROM. So basically the first thing we want to do is select the device type. So up in the top left hand corner here we've got to select, and basically that brings up device listing and manufacturing device type. So for EEPROMs, flashes, PLDs, serial EEPROMs, that sort of thing. So my device is a Texas Instruments, it's TI 27C256, there it is there, and I'll OK that. And basically the information page then will change to show you the information. I'll give you a little bit more technical information as to regards the size of the EEPROM, the voltage, the 5 volt supply, and its VPP pin, which on EEPROMs is the programming voltage. So that's, in this case, it's a 12.7 volt programming voltage. Another good thing is it'll actually give you the orientation of the EEPROM in the actual ZIF socket itself, so we can get it plugged in exactly the right place. So I'll go ahead and do that now. So here we go. So ground pin on EEPROM's top right hand corner, so that's going to go in like that. Pull the handle down and then I can rest it back down on the workbench. So that's EEPROM already. So the next thing to do is load the actual code. So I've got a load button at the top left hand corner there. I've got various ROMs that I've saved onto my computer for the Spectrum. So I'm actually wanting to use the dual GW03 and original as we showed you in the hardware. So I'll select that one there and open that. And it's a bin file in this particular case. And there it is there, it's loaded in there and it's giving you a little preview of the actual code. I know that the Spectrum ROMs start with F3AF, so I know it's loaded it fine, and of course this is just the ASCII on the right hand side there, we can ignore that. So then the next thing to do is we've got up at the top left here, we've got the programming button. So it's just a case of hitting the button there and off it goes. It's running through the testing to see that the EEPROM's blank. Okay, so it was. Now it's loaded the bin file, and now it's actually sending it to the EEPROM so you can see the program in there. So it's going to go through the program step, and once it's done that, it's then going to verify, it's going to read back the code to make sure that it actually matches what was sent to it, so it's basically a verification. And just off camera there, the actual light on the programmer is actually flashing away, the red LED, basically just to show that it's active there. That's the programming done okay, and it's actually verified it fine. So we're actually done. So now I can remove the EEPROM from the programmer and take it over to the Spectrum. I've also just temporarily fitted a wee heatsink, smaller than what should be on there, just temporarily, allow me just to get 5 minutes out of it when I power it up, just for testing purposes whilst I test the EEPROM, etc. So let's plug in the EEPROM. Yep, that's EEPROM plugged in, right way round. And now we'll go off to the display. Here, zoom in. I've got the video lead obviously plugged into the Spectrum as well, so let's power it up. I've got the switch on the Spectrum set to the 0 volts position, so that's actually going to load, hopefully, the bottom end of the EEPROM, the ROM at the bottom end. So here's power on. Wow, perfect. Got the startup screen just first time there. Obviously I can't do anything at the moment, and I got the keyboard plugged in, so I think what the next thing I'll do before I go any further, I'll plug in a keyboard and let's see if we get some response. I'll just temporarily just lay it down there, it should be good enough. There's nothing to short out, so it should be fine. Back to screen again. Okay, so as I said before, I've got two ROMs fitted. The first ROM at the bottom end is the bog standard original ROM. So I'll just put power back on there, and the difference between it and the upper ROM that I've put in is basically the new ROM will give single letter per press of the keyboard. Unlike the original ROM, we press R and you'll get the whole word run coming up, for instance. So I'm at the bottom end, so I'll just hit the enter there, and I'll just press the R key. And as you can see, I've got run coming up on its own there. So that's obviously the original ROM. So I'll power back down again, put the switch in the other position, so hopefully this will now load the upper ROM, the modified one. Put power on, and I'm getting a logo again, so that's good. Press enter. Now I'll press R, and I'm only getting the letter R, so I should be able to continue and type RUN. Perfect. So the next thing to do is disconnect all the cables, put back on the original heatsink, bolt it all up, put the case on, and then that's it. Job done.